Listen, man, this is not working out for the channel. Like, not at all. We are actually losing subscribers over this series. How can you possibly sit here and try and tell me that this series is working out and it's fucking doing good? It's not, okay? You hire me thinking I know anything about astronomy, even though I've told you multiple fucking times that I took a course of astrology in high school. Well, hello again, everybody. Welcome to another episode of Astronomy 101. And in today's episode of Astronomy 101, we will be discussing the Drake equation, or as I like to call it, the equation for the probability of life. Because essentially what this equation does is you take a chunk out of any galaxy, right? And you count all the stars in it, and from there, those number of stars are going to slowly begin to dwindle down because we're trying to figure out of those stars how many of them actually have solar systems, and then we try and figure out how many of those solar systems have planets within a Goldilocks zone, and then from there we try and figure out of the planets that are in the Goldilocks zone how many of them actually have life, and then from there we try and figure out, okay, of those planets that actually have life in them, how many of them are intelligent life? And then from there, after we figure out the intelligent life, now we're trying to figure out, okay, of the lives of the species that are actually intelligent, okay, how many of them have been able to actually make some form of communication that could be intercepted by us, right? Now this could be like radio waves, for instance. That's the most like common kind, right? So say radio waves that one of our satellites will intercept and then transmit back to home, right? And then now here, as human beings, we're reading and we're listening to this radio signal of the species, and they're all like, and from there we're like, holy shit, that must be an alien. Let's get out there, right? But then this is where the little equation gets pretty interesting, right? It is very likely that by the time we transmit that radio wave that the species had sent out, it's very likely that we got it hundreds of years after it was sent out. And that being said, it's very likely that by the time we finally arrive at the planet with the alleged species on it, the planet will already be eradicated and all life forms on it will be dead. Yeah, that's essentially the Drake equation. So if we're thinking about how this applies to things that we know currently, I like to talk about Venus. Venus is one of the most interesting planets because it's in our solar system, right? And for the longest time, everyone's perception of Venus has been that it's an absolute hellhole. There is no way that any life could have possibly existed on there. It has been and will forever be hell. I was going to say hell on Earth, but obviously it's not on Earth, right? But everyone says that Venus is basically hell, that no one wants to be there, right? But here's something really interesting, okay? So a few years ago, we have uncovered some new information about Venus. And this information is that a long time ago, it is very likely that Venus used to be like Earth, right? But then something of a greenhouse effect happened to the atmosphere. It began getting a lot denser, or smoke, or whatever. Basically, the clouds around Venus began to become really bad, and the atmosphere just started getting absolutely fucked, right? Creating the greenhouse effect, right? Meaning every single thing on the planet would start to get really, really hot, right? Because the heat that was radiating from the planet itself was not able to escape the planet and got caught in the atmosphere, which then sends it back down into the planet, basically making the planet what it is today, an absolute hellhole. But think of this. Since they're saying that it used to be just like our planet, there's also been theories roaming around that they found evidence of like columns or whatever, or things that are not naturally made, right? And so there's a lot of speculation that there used to be life on Venus. But, and there's a big but, after all of the effects of the atmosphere that on Venus, all life has died, right? What I'm saying is it's very possible that there is life out there in the universe somewhere, but it's not gonna matter because by the time we finally catch wind of it, they're probably already dead. Planets cannot sustain life forever, right? Take a look at planet Earth, and by no means am I trying to get all like, go green, Bo, go green. There's no way that the planet Earth is going to be able to sustain life for more than another couple million years. So Earth definitely has an expiration date. The human race definitely has an expiration date, alright? And the big goal for a lot of scientists, a lot of astronomers, is to be able to sustain human life for as long as humanly possible. Meaning, we want to make sure that by the time Earth has reached its expiration date, we have a plan B. We have somewhere else to go. So, that's the Drake equation for you guys. You gotta love today's discussion about the gloom, the death. So I just want to say a quick little message to anyone who's watching. Next week we will be talking about stars because I love stars. I love stars, and included with this discussion, we'll be teaching about solar weather, because solar weather is a real thing. Space weather, let's call it that. Space weather. Weather in space. And we'll be talking about that in the next episode, and it's going to be great. Seriously, dude.